Write a synthesis for the synthesis of the following aldehydes and ketones. Give them structure, proper name of the starting materials, if you can do so. But anyway, the way that we really know to synthesize most of these is simply by oxidizing alcohols. Oxidize a primary alcohol gently, and you make an aldehyde, oxidize a secondary alcohol, and you make a ketone. So that's pretty much what we're going to do here. So diethyl ketone, there is the structure of diethyl ketone. So that's a ketone, so therefore we want to take a secondary alcohol that essentially just has an OH where the O is. So there we are, that one there. It's a pentanol, 1, 2, 3, 4, 5. Alcohol group of the 3, so 3-pentanol. Put that in. It's a regular old oxidation, don't have to be too careful. So our favorite one for that would be a potassium chromate or potassium dichromate, as I put here, with H2SO4 and refluxing it. 3-methyl-butanal. So here we've got an aldehyde at the end of the 1, 2, 3, 4 carbon chain with a methyl group of the 3. So this is of course going to come from a primary alcohol. So this carbon, instead of having a double bond O and an H there, will just be a primary alcohol one. So it'll be a CH2OH, just like that one. Okay, so again, notice the methyl there, the same. We've still got the 4 carbons in the chain. So 3-methyl-butane, 1-ol. Now, of course, A level would have you just do that same reaction with the acidified chromium 6, and just be careful and pull it off early. Much better to do it with PCC and CH2Cl2. So in other words, in anhydrous conditions, using a very nasty solvent and using that pyridine chromium salt. 2,2-dimethylpropanol, again it's an aldehyde. Let us just replace the aldehyde group with the primary alcohol group, as you see there. So 2,2-dimethylpropan 1-ol goes to 2,2-dimethylpropanol, excuse me. Again, in order to do a primary alcohol to an aldehyde, we have to use the gentler oxidizing conditions of PCC in an anhydrous solvent. This group, by the way, here, a CH2 with then what's effectively a tert-butyl group, is sometimes called a neopentyl group. It's a fun little group because it's a primary group that's got a huge amount of steric bulk on it. So later on you'll see how neopentyl groups can change the reactivity of substances that they're attached to. Not because there's anything different in the electronics of them, but because it's a really big, bulky group. So continuing on, methylpropyl ketone, looks like that one, comes from 2-pentanol. So of course, anytime we want to turn a secondary alcohol into a ketone, we just have to have fun with the acidified chromium 6. Benzaldehyde, well, there's a benzaldehyde there. It's an aldehyde group. How do we get to an aldehyde group? Well, we can just go from the primary alcohol. So again, turn the aldehyde to the primary alcohol. That carbon has got double bond O and an H. So the carbon's got 2 H's and an OH. And of course, it's a primary alcohol to an aldehyde. So we want to go gently with it. So PCC. Now, just so you don't get too bored, acetophenone is this species here. And this is a aromatic, a benzene ring that has this C double bond O on it. And you might recognize this type of product as coming from a Friedel-Crafts acylation. So let's do that for fun, shall we? Let's take benzene and let's react it up with the CH3, C double bond O, and then Cl here, otherwise known as ethynyl chloride. We'll see how we name such species in the next module. And of course, when you've got a Friedel-Crafts reaction, you need to have a Friedel-Crafts catalyst in there. So as we're using the chloride, let's use aluminium chloride or iron chloride for fun. So anyway, just to break the monotony of all these oxidations, you can make an aromatic ketone like this one, a ketone that's bonded to a benzene ring, whatever the rest of the molecule might be, using a Friedel-Crafts acylation.